Guys, welcome back to TechDose, and in this video we will look at construct string with repeat limit problem, which is from Leetcode number 2182. Let's now look at the problem statement. In this problem you are given a string s and an integer repeat limit. Construct a new string repeat limited string using the characters of s such that no letter appears more than repeat limit times in a row. You do not have to use all the characters from s. Return the lexicographically largest repeat limited string possible. You are also given the definition of the lexicographical ordering here, so you can just go through that once. And if you look at the constraint, they are saying the n size, that means the size of the string, will be 10 to the power of 5. So don't bother about writing an n square algorithm which will be 10 to the power of 10. Here an n log n or n root n algorithm will pass, or even an order of n algorithm will pass, right? Because our goal is to always write an algorithm with less than 10 to the power 8 computations. Now let's look at an example for better understanding. In this case, let's say that our given string is having 7 characters, and let's say our repeat limit value is 3. Now our goal is to build the lexicographically largest string where no same characters occurs more than repeat limit times. Now let's first understand about the lexicographical ordering if you are not really sure about it. So let's say you have string s1 and s2. If you match going from left to right, then the first character where they do not match, that means the third character going from left to right, is the one where s1 do not match with s2. So if you find a higher character in a string, then that string will be larger than the other string. That means in this case, you see at s1 third position is a, and at s2 the third position is having b. So b occurs later than a in the alphabetical order, right? And therefore s2 will be larger than s1, lexicographically larger, right? If you look at another example, like let's say s1 and s2, then even the length wouldn't matter. Okay, it is not like the length should be same. You just follow the same technique, go from left to right, and the first mismatch position, you check it out. In this case again, c is larger than b, therefore s2 will be larger than s1, even though s2 has less number of characters, right? The number of characters wouldn't matter here. But if you look at the third example, then in this case if you start matching left to right, then everything matches, and when you reach to the third character, then s2 do not have the third character. So if everything matches, that means one string is a prefix of the other, then the larger string will be always larger. So in this case s1 is larger than s2, right? So I hope this provided you clarity on what is lexicographical ordering. So given string s1 and the repeat limit, let's say 3, we want to build the lexicographically largest string possible where you cannot use more than repeat limit number of same character side by side. Okay. Now in this case, what you can logically do is build a map, that means a frequency map out of the given string, where you will count all the unique characters. So a has occurred 2 times, b has occurred 1 time, c has occurred 4 times. Okay. Now greedily what you will try to do is, since you want to build the highest string, I mean the largest string, therefore you will always go for the largest possible value, that means c, not according to the frequency. Okay, it is according to a to z ordering. So a will have value 0 and z will have value 25. Let's say this is what you are assuming. So whichever has the higher ASCII value, so c will have higher ASCII value out of all this. Therefore you will greedily pick c as many times as you can. So in this case the limit is 3, so I'll pick c 3 times. If the frequency of c was less than 3, then I will pick c for less than 3 times, right? I cannot pick more than repeat limit times, but if I have less frequency, I'll pick less times. You pick c 3 times and then change the frequency to 1. Now the next character cannot be c. So what I'll do is I'll pick the next best option, which is b. I cannot pick a because there is b which is larger than a, right? So I'll pick b, I'll place a b, and immediately I'll just change the frequency and again go back to picking our next best option c, because again I can pick c once the substring has broken, right? So I can again pick c. Now how many times can c be picked? There is only one frequency of c and the limit is 3. So definitely I have to take the minimum of both these values, so c will be taken 1 time, right? And after this the frequency is 0. So I will go to the next best option b, its frequency is 0. I'll go to the next best option a, its frequency is 2. So a can be put 2 times here, right? Because it is occurring less than repeat limit times. And now you can set its frequency to 0. So once you have run out of all the characters, or you cannot further make the string, then this is your largest possible string that you can make, and this is our answer. So I hope you have got the idea of how to solve this problem. Now Even if you have the second string, let's say you have 5 C's together and your repeat limit value is 3. If you build a frequency map, then C has occurred 5 times. This is the only value that will get inserted. So C can be inserted minimum of 5, 3, that means 3 times. And after that, you will look for the other option, but there is no other option. That means this will be the answer. You cannot put any more C's, right? So your answer can be of lower length than the input string as well, right? If you solve by this technique, then for every positioning, you might have to iterate through all the characters, find out the best option possible, and then you place it here. So this will be kind of 26 times of n, and here n can be 10 to the power of 5. So if you multiply by 26, then it will be 2.6 times of 10 to the power of 6. And since I said that you have to write an algorithm less than 10 to the power 8, so this is going to pass. But we still have a better approach to understand. So let's go and try to build up our intuition. Now let's understand a little bit about the weightage. Now if you are given a string, let's say 3 A's, 4 C's and 3 B's, then in this case I will always assume that the highest weightage will come on the left side and the lowest weightage will always be on the right side. And if you move from right to left, then it will be in the terms of increasing weight. Like how you take a base 10 number system, right? In a base 10 number system, if you have 2, 3, 4, 7, then the first 7 is having the least weightage, that is 10 to the power of 0. It is a ones place. If you look at 4, it is the tens place. If you look at 3, it is 100s place. And if you look at 2, it is the thousandths place, right? So you know in the base 10 number system how the weightage increases moving from right to left. Similarly in lexicographical system for the string as well, it is the same. Now if you want to build the largest number out of this given number, then you can just sort all the digits in descending order and you will get always the largest possible number that you can build. So you will have 7432 in such a way that 7 is the largest single digit number, and that has to be put at the highest weightage position, right? This weightage is 1000. So if you put the largest digit at the highest weighted position, then you get the maximum number, right? So similarly, in case of string as well, we will greedily place the highest valued item to the highest weighted position, right? We will follow the same concept. Now let's look at our greedy idea and how to solve this. After this, I'll be showing you the dry run. Now in this case, given the string and the repeat limit value, I will build the frequency map out of it, let's say. And once I have built that, each of the character frequency, then I will know that A will have the least weightage and Z will have the most weightage, which is 25. You can also take in terms of ASCII value, which is 97 to 122, whatever, right? So in this case, I will be checking and trying to put as many items in the beginning as possible for the highest weighted item. So in this case, the highest weighted item is C. I'll just search for it. C has the highest weightage, right? So I'll try to place C. But how many times can C be placed? It will always be minimum of the number of times C is occurring in the given string. So 4 comma whatever is the repeat limit, so it is 3. So it will be 3, right? So I can place C 3 times, let's say, and so the C's frequency will decrease by 3 and it will become 1. Now the next character here cannot be C. So what I'll do is I'll pick the next best option, which is B, okay, the second highest weighted item, and I will put only one instance of this, not multiple instances, only one instance. And once I have placed this, then I'll again go back to the highest weighted item and place as many items as I can. So in this case, I will be placing minimum of 1, 3, that means one time, and this frequency will be 0. So I can just remove it from the map. Okay, so we are done with C. Now the next best option is B. So I'll place B one time because the minimum of 1, 3 is only 1, and this will become 0, and I can remove this. And now I can place A. So A can be placed minimum of 4, 3. So 3 times A will be placed and this frequency will become 1. Now the next frequency has to be something else other than A. We cannot place another A. So there is nothing else available. So we are done, and this is the answer. Okay. So I hope you have got the idea of how we will be solving this. Now in this entire approach, you might have seen that I was always picking the item with the highest weight. So if you have to always pick the item with the highest weight, then the best data structure to do that is maxheap, isn't it? So maxheap will always give you the highest weighted item in order of one time, and you can extract it in order of log n time. If you want to understand heap in detail, you can click on the I button and also find the link of the entire heap playlist in the description below. So let's move forward. Let's see how to solve this entire problem using the greedy character pick using maxheap. So if you build a maxheap out of this entire string, then what I'll do is I will be taking the character and its frequency and build it as a pair. Why not frequency comma character? Because I want the maxheap to be sorted by character in such a way that A will have least weightage and Z will have most weightage, right? So I need sorting based on character. So that is why I will be taking character as the first item and frequency as the second item. Okay, I have already built the maxheap, let's say. So once I have done that, then I have the repeat limit value as 3. So I'll try to build my answer string. So how to build that? I'll be taking out the maximum item here. So the maximum item is C, 4. C, 4 is taken out and it will be written 3 number of times. Why? Because we will always be writing it minimum of 4, 3 times. 4 is the frequency of C and 3 is the repeat limit. I cannot exceed repeat limit, right? So I will change the frequency of C. So frequency of C will become now C, 1, 4 minus 3, right? Because 3 times you have inserted. If this frequency is still greater than 0, then what I will do is I still want to put C, but I cannot put C. So greedily I will always try to pick the next best option, and once I put one instance of it, then after that I can place C's again, right? So what is the next best option? So here the C's frequency is greater than 0, so I'll pick the next best option, which is B, 2, right? If let's say this heap would have been empty after removing C, then it would not be possible to place anything, and I will just break and say that triple C is the answer. Let's say everything was C now, then triple C would be the answer, right? Because I cannot place any more C, but still my heap is not empty. I still have 2 items. So I'll pick out the next best option and I will place one frequency of B, and I will reduce its frequency by 1 time. Now if B's frequency was already 1, then it will become B, 0. Okay, and then I will not push it back into the heap because it cannot be used. But in this case, B's frequency is 2, and so this frequency becomes 1 and still it can be used. So we will be pushing it back into the heap as B, 1. And now again this C, 1 will be pushed into the heap as well. And once you have pushed both the items, again we will redo the process. Pick the one with the highest weight C, 1, and I will be writing this C 1 time because it will be written minimum of 3, 1 time. And now since this frequency has become 0, so I will not push it back. Again I will repeat the process. So in the process I will be picking out the next best option, which is B, 1. Okay, so B, 1, B will be written only 1 time, and for B, 1 its frequency will become 0. So I will not push it back. Again the next time I will be picking the next best option, which is A, 4. Now how many times will A be written? 3 times, because it will be minimum of 4, 3. So A will become A, 1 now, because A now has frequency 1 left. Now I will check that I will have to put something else so that again I can restart putting A's, but the heap is empty. That means there is nothing else except for A, and that is why I have to stop here, and this is my result. Okay, so I hope you have got the entire approach. Now for this particular case, what can be the heap size? The heap size cannot go beyond 26 because we have alphabet size from A to Z, which is only 26, right? So each of the push and pop operation takes log of 26 times, which can be considered to be order of 1 because 26 is a constant, right? And the space complexity will also be order of 26 because 26 is the size of the heap, and the resultant string will not be considered in the extra space because we need to return it, right? So I will be taking it as order of 1. Therefore the space complexity is order of 1, and the time complexity being n, log of 26 will be order of n. So I hope you were able to understand this solution. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, we are given the string and the repeat limit. I'll be finding out the frequency of each of the character from the given string, and then I will be building my max heap by inserting the character and its corresponding frequency as pair into the max heap. Once it is done, I'll be taking the resultant string, and after this I will be processing each and every item of the heap until the heap becomes empty, right? So in the beginning what I'll do is I'll be picking out the top of the heap. Once we have picked it out, I'll be finding the character and its frequency. So how many times we can write the current character, it will depend on the current character's frequency and the repeat limit. So if the frequency is 2 and limit is 3, I'll be taking the minimum of both of them, which will be 2. But if the current frequency was more, then I will be taking it repeat limit times, which is 3, let's say. So I will be appending it at the end of the result using the append function, and the frequency of the current character, like let's say there was a with frequency 4 and I have inserted a 3 times. So this 4 will be decreased to a value 1. So frequency is decreased now. And now if the frequency has become 0, like let's say if it was a comma 0, then I would not insert it back into the heap. But if it is not 0, it is a value greater than 0, then I will greedily want to put something else as the next character, so that again I can start putting a's, right? So if I see that the frequency of this current character is greater than 0 and the heap is empty, that means there is no next character to be put, and so I'll break out. That means we are done. Otherwise, if there is a next option to be put, then I will be putting the next option and then only one character of it, okay? And then I will decrease its frequency by 1 time, and if this next character's frequency happens to be greater than 0, then I will push it back into the heap, otherwise I will not push it back, okay? And then I will push back this a's frequency as a comma 1 into the heap as well, and I will again repeat the process. So once the heap becomes empty, that means we are done with the entire processing. Then my resultant string will be returned as an answer. So I hope you were able to understand this approach. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.